Hey, it's Hutch here, and we are on Module 2 now. Before we get started, I wanted you to see the three things that I have in my Module 2 subject here. I have my Module 2-1 notes. I also have the 2-1 practice homework. But the third one in the middle there is a fraction to decimal chart, and that's in Schoology in your resources folder for our course. So make sure you have that. It's going to have a mix of common and also some uncommon fractions along with their decimals. Okay, and we'll be able to use that a lot throughout this module. Taking a look at the entire module, you can see that we're going to be figuring out percent of change, tax, tips and markup, discounts, interest, commissions and fees, and percent error. A lot of real life application concepts, which is really neat. Vocabulary-wise, some vocabulary that maybe looks familiar to you, and maybe some that aren't, like simple interest, or maybe wholesale cost, or maybe some of these look familiar, just not sure what to do with them. Okay, all right. Let's go ahead and take a look at our lesson today. We're going to go ahead and skip through that part and head right to lesson 2-1. Okay. Your vocabulary today, we're going to be learning about percent of change in regard to decrease and increase. Before we do, let's talk about some reminders here. To move from a fraction to a decimal, remember a fraction is just division, and so we would divide the numerator by the denominator. Excuse me. A decimal to percent, though, when we have a decimal, we're going to multiply by 100, or the trick is move the decimal point 2 places to the right. So let's list some examples here. Fraction to decimal, let's say I had 4/5 as a fraction. That's a bad example. Let's do 4/6 as a fraction. All I would do is on my calculator, it says divide the numerator by the denominator. And so I have 4/6, and it's 0.6 repeating. So 0.6 repeating, and there we are as a decimal. Okay, decimal to percent. So let's say I have 0.4 as a decimal, and I need to change it to a percent. Well, it says multiply by 100. And multiplying by 100, you would swoop 2 spots, because times 100, there's 2 zeros here. And so that's what how that moves the decimal point, because times 10 is 1 spot, times 100 is 2 spots. And then you just fill that gap and really place your decimal point strong there. And so we end up with decimal to percent, it goes over to 40, which equals 40%. Okay, so that's that one. Percent to decimal is just the opposite. So we're dividing by 100, moving the decimal point 2 spaces to the left. Okay, times 10 is 1 spot to the left, or sorry, divided by 10 is 1 spot to the left, divided by 100 is 2 spots to the left. So if we had 36%, all I would do is I would find my decimal point here and divide 2 spots to the left, divide by 100, and I have 0.36. Okay, all right. Because realize percent means divided by 100. Okay, if we have percent and we want to change it to a fraction, okay, it says write the percent as a fraction by dividing it by 100. Okay, because that's what a percent is really. And so if I have, let's just say 25%. Okay, 25%. Okay. It says write the percent as a fraction by dividing it by 100. So we would take our 25 divided by 100. That's what a percent is. Okay. And then simplify it as a fraction. So right now we have 25 hundredths. That is the percent in fraction form, but we do have to simplify it. So that one's a nice, easy one to simplify, but I do want to show you on the calculator. We would type 25 divided by 100, and then the Desmos calculator is really nice because it gives the decimal, but if you hit the little fraction circle next to it, it'll show the simplified or reduced amount, which is 1/4. So that's really what we have to write. The simplified fraction for 25% is 1/4. Okay. All right. Here's some practice problems for us to try together. It's a mix of some simple ones and also some really complex ones that I would like you to see how to handle them. That way you have them as an example to reflect back on if you ever see something wild like those in the future. All right, so percent to fraction. Remember, it says write it as a fraction and then simplify as possible. So 40%. Okay, remember that per is just the fraction bar and cent means 100. Okay, and so we have 40 over 100, that's 40%. That's what that language means. And then we just need to simplify the 40 hundredths. So maybe you can think through that, maybe divided by 20 over 20. Let's go ahead and see what 40 divided by 100 is. 2/5. So simplified, we have 2/5 percent to a fraction. I'm going to circle my answer. Okay. All right, next one is 17.9%. So I'm going to write it as a fraction first. So 17.9% or per 100. Okay. And then we need to simplify that. So let's go ahead and clear and type that in. 17.9 divided by 100. Okay. And you can see it simplifies to 179 thousandths. So the reason that is because typically you don't want to leave a decimal in the numerator. And so I can just multiply by 10 and multiply by 10. Oops, sorry. Here's my decimal point here. Multiply by 10, and you can see I end up with 179 over 1,000. Okay, and so that is the simplified fraction with no decimal in the numerator. And there's my answer. So that's one unique one to be aware of. Okay, next one is a mixed number as a percent. Okay, and so we know 1/4 as a decimal is 0.25. So really we have 26.25%. And remember, first step is just say per cent. So there it is as a fraction. Okay. We know that we do not leave the decimal in the numerator. So let's multiply once by 10 and another. So multiplying by 100, take your decimal there and go swoop, swoop, the same amount, just equal amounts from their decimal points. And you can see what we end up making. We have 2,625 over a 1 with 1, 2, 3, 4 zeros. So that's 10,000. Now I know that it ends in a multiple of 5. We have a 5 and a 0. So it will simplify down. Let's go ahead and type this in. 2,625 divided by 10,000. And let's see what we shrink down to. 21/80ths is our simplified fraction. 21/80ths. And there we go. Percent to a fraction. So a couple weird ones there to be aware of. All right, fractions to percents. Okay. One of the easiest things to do, notice up here we don't have a fraction to a percent. But if you have a fraction, it's really easy to make a decimal, and it's really easy to turn a decimal into a percent. But one of the things I'm going to look at, though, is I already have a percent, right? And 19 out of 100, I just know that that's 19%, okay? Because it says percent right in the fraction, 19 per 100%. So that one's already done. Let's go to 3/5. I could turn the fifths into hundredths and make the equivalent fraction, but really remember I have to create the equivalent fraction, make sure all that works. The easiest is just to go 3 divided by 5, and I get 0.6, and it's really easy for me to turn a decimal now into a fraction, okay? So remember, I just go from decimal to from decimal to percent is just multiply by 100, okay, which is also 1, 2 swoops. And so there we go. Make that stand out. And so I have 60%. Okay. All right, let's look at your next one. We have 3 200ths. So let's just make the decimal and then turn the decimal to a percent. 3 divided by 200 is 0.015. How do I turn that decimal to a percent? Remember, we multiply by 100, 2 spots to the right, and so we end up with 1.5%. Okay. All right, so there's fractions to percent, a couple different ways of how that works. All right, let's look at decimal to percents now. Okay, I love decimal percents, nice and easy. When we have a decimal, we just got done doing this. We just multiply by 100, so moving it 2 spots to the right. So we have 44%, okay, because that was 44 hundredths anyway, so that makes sense. All right, multiply by 100, whoop, whoop. So we're at 0.38%. I moved it, multiplied by 100. Now this one's a little bit tricky because of the repeating decimal. So ready, let's multiply by 100, 1, 2, and I have 14.2857. But I can't stop there because this was a repeating decimal. It went on forever. So you have to sort of think about this a little bit. What was after the 7 in the original number, in the original repeated amount? Okay, good. It was after the 7 would have been a 1 again, okay? And so I have a 1. What was after a 1 was a 4. And that is what ends up repeating, 285714, 285714, and so on, okay? So I have 14.285714 repeating, okay? And this is percent, because I just multiplied by 100, which makes percent. Now, here's the thing, though. This is where our fraction to decimal chart is going to be a little bit nice here. So let's bring this out. Look at some of the long, weird repeating decimals. Do you see any that say 0.285714? Yep, right there, 2/7. Okay, so really what this is that I can write is 14 2/7% if you want to clean it up a little bit. Okay. All right, so there's that one. Let's go ahead and take a look at percent to decimal. Okay, remember percents literally just mean divided by 100. Okay, and so the trick is, if we're dividing by 100, is move the decimal point 2 spots to the left. Okay, so always place it first, then do your 2 swoops, 1, 2, and so that is 0.02. And if you want to fill it in like that, you can do that too to help you see it. Don't just start with a point. Make sure you put a 0 in front of the decimal point. But there you go. There's percent to decimal. Okay, 4 5/9%. Well, it's not a nice decimal situation there, so I have to figure out what 5/9 is. So either look at your fraction decimal chart, or that's also a quick calculator check. And so 5/9, everything over 9 is going to be a repeated decimal. So it's 0.5 repeating. Okay, so really I have 4.5 repeating percent. Now, one of the things I want you to notice is this is still a percent because look, the decimal point was right here and it still didn't move. It's still after the 4. Okay, so it's still a percent if the decimal point didn't move. So right now I have 4.5 repeating percent, and I need to move the decimal, okay, 2 spots to the left. So let's go ahead and move that. So we have 1, 2, and so here's my new number, and I have 0.045 as my decimal, okay? But remember, that 5 goes on and on and on and on. So that's the tricky part with something like that, is the 5 is repeating. So it's 0.045 with the 5 repeating on forever. Okay, so that's percent to decimal. Okay, I'm going to give that a circle. All right, next one is 37.5%. Okay, so remember, we're just moving the decimal 2 spots to the left. So 1, 2, and put the decimal point. And so we have 0.375. Okay, but this one does not have a 5 repeating. And so we go from percent to decimal, and that is it. Okay, all right, let's go ahead and move on to your actual lesson today. And your first part of your lesson is percents of increase. Okay, and here's the basics of how this works. We're going to use this change formula, and I really like this. It's end minus start, because think about it. When you're finding the difference between things, the word difference means subtraction. So we're going to use that understanding, and this is your formula, end minus start over start, and that's going to come up with a decimal for you, and then you change the decimal to a percent. Okay, if it goes from small to big, you meaning start to end, being an increase, then that's what you need to share at the end. If the start was big and then it went small, then obviously there was a percent decrease. So you have to pay attention to that. I'll show you what I mean right here. Okay, so walk through this. I want you to see all my expectations. The enrollment at a middle school increased, so they're already telling you increased, from 650 to 780. I want you to label your start. Okay, so there's my start. And here's my end. Okay, so you have to notice that. Okay, and label that every single time. What's the percent of increase in the number of students enrolled? Okay, so on the side here, we said the formula for percent change is end minus start. So I want you to write end minus start like that over start. Okay, and then let's go ahead and actually fill that in. Okay, so now it's just plugging in those variables. So it's 780 minus 650 over the start again, which was 650. And then continue over, or you can continue down now. So let's see what we have. 780 minus 650. So we have 130 divided by, oops. I guess we could use parentheses to do that. 780 minus 650, end minus start, end parentheses. And all that is divided by the start, which is 650. So notice the 650s are both on the right, because it's end minus start over start. And we have 0.2 as our decimal. Okay, so here's where we're at so far is 0.2. Okay, now that we have that, remember that creates a decimal. Okay, that's this step right here. Okay, now that we've created a decimal, we need to change that to a percent. How do we change that to a percent? We multiply by 100. Okay, so I have my 0.2 and I multiply by 100, so 1 swoop and 2 swoops. And so that puts my decimal here, and that equals 20%. Okay, and so what you have to write, though, you're not done. From start to end, that was an increase. So it was a 20% increase is what you actually need to have circled. Okay, so go ahead and try it out here with this check. Okay, imitate the same thing. So you can pause if you want, or if you want to just keep following along, you can. A certain brand of shampoo contains 12 ounces in a bottle. They redesigned the shape of the shampoo bottle, and the new one contains 15 ounces. So what is the percent increase in the amount of shampoo in the new bottle? Okay, so what was the start? It was this. It's now this. You can see how I'm tagging it if I don't have space. Okay, and we do end minus start over start. So go ahead and set that up now. So end was 15 minus 12 over 12. Okay, notice those match up just like they matched up here. It's a common thing you're going to see, n minus start over start. So we have 15 minus 12 is 3, right? And so we have 3/12. And what is 3/12 as a decimal? Well, let's see. 3 divided by 12 is 0.25. Okay, that's the decimal. Now we need to change it to a percent. Okay, how do we do that? We multiply by 100, which is 2 swoops to the right. Okay, and I end up with 25%. And then we look from start to end. Did the number go up or go down? It went up, so that's increase. Okay. If you know that right away, that's something that you could make a little note with an arrow up or down ahead of time as well. All right, example 2, percent of increase. Let's check this one out to get some more practice. Average cost of gas in 2000 was $1.50, so that's my start. And now, suppose you purchase for $3.30, that's my end. What was the percent of increase? Okay, so I know it's going up. I may even make a little note over here with an arrow to know I better write the word increase. I don't want to forget. All right, so end minus start over start. I'm going to write that formula every time so I don't make mistakes. The end is $3.30. Start is $1.50. Over the start is $1.50. Okay, and now I can go ahead and plug this in. Okay, so I'm going to do my parentheses. 330 minus 150. Oops. Minus 150 in parentheses divided by the start, and minus start over start. It would help if I put a decimal point in there. All right, and we have 1.2 is our decimal. That's just the decimal. We need to multiply by 100 to create our percent. And look at that. We have 120%. So interesting. Can you have more than 100% change? Yep, you can. If I left it like that, why would I lose a point? Oh yeah, I forgot to say 120% increase. So got to make sure you have that word. So it's something to check every single time. Okay. And so think about, why was it 120% increase? Okay. If we were at 150, another one of that, if 150 is the main amount, I added a whole nother $1.50. Okay. That put me at $3 and another 30 cents. Okay, and so that's why we went 120% increase. We overshot the 150 total even more. Okay, all right, go ahead and check with this one. Okay, so again, you can pause if you want or just follow along. Frankie calculated she would need 9.5 yards of wallpaper. The wallpaper she chose had a large pattern, so instead she needed 13 yards. What's the percent increase? Rounded to the nearest percent. So here's my start. Here's my end. What's my formula? Say it if you know it. End minus start over start every single time. And you have to have your labels. So we have 13 minus 9.5 over 9.5. Okay, so we can go ahead and plug that in now. I'm going to do my parentheses. 13 minus 9.5 and parentheses divided by 9.5. And we get this decimal, 0.3684, with a bunch of other stuff. 0.3684. So let's just 3684. Yep. Okay. Now that's our decimal. Remember, we multiply by 100. 1, 2. So I end up with 36 0.84 and a bunch of other numbers. But remember, the reason I didn't list those, it said round to the nearest percent. So if I have 36.84 and I'm cutting it here at the nearest whole percent, this is really 37%. Okay, and look again from start to end. Yep, our numbers went up, so it's 37% increase. And there we go. Okay. All right, so now we're doing the opposite, which is percent of decrease. It's the same exact process, but from start to end, our numbers are going down. But it's the same idea, same process. Okay, so stick with that routine. I promise it's going to work for you. All right, at the beginning, the volume was 25.2 milliliters. Beginning means start. And then the volume dropped. That's the end. Since it dropped, pay attention that it's a decrease. Okay, so we're going to do the same thing, end minus start over start. Write the formula every time so you get in the habit and don't forget. Now the end is the 18.9 minus the 25.2 divided by the start, which was the 25.2. You are going to have a negative number in the top, and that's okay. Okay, so let's play this out and see what happens. Okay, so in parentheses, my 18.9, I guess I could actually write that. Okay, minus the start, 25.2. It would help if I put minus. Okay, and then divided by the start, 25.2, and we get a negative 0.25. Okay, I want you to see what that means. So negative 0.25. Negative just means that our percent is going down. Okay, so right now that's just the decimal. So remember, we multiply by 100. Okay, and I have a negative 25%. But we're not going to write negative 25% because we have a different word we're going to use for a negative percent change. So we're just going to say 25%, and then we use the word decrease. So if your answer is ever negative, it's a great reminder that that's a decrease percent change. So let's try it with this check here. When resting, a spring measures 73.3 millimeters, and when it's compressed, it measures 51.29. What percent of decrease in the length of the spring? Okay, so here's our start. So we always are going to label that first. Here's my end, and it says round to the nearest percent if necessary. So we'll see if we do. All right, write your equation out, end minus start over start every single time. And now let's just be really careful. So we have 51.29 as the end, minus the start is 73.3, all divided by the start, okay? And then we can go ahead and see what that is as a decimal. So let's go ahead and type that in. Okay, clear. So open parentheses, 51.29 minus 73.3. Close parentheses, and then divide it by the start, 73.3, and let's see what we get. We get another really long decimal, okay? So I have a negative 0.3002. I don't have to go that far because remember I'm going to be multiplying by 2, so I just need to see, I really didn't even need the 2 in there, but because we're going to be multiplying by 100, which puts us there, and I can make my rounding decisions with that amount. Okay, so I'll leave it at that, and then we need to take the decimal and change it to a percent by multiplying by 100. So it puts us right there at 30. So we end up with a negative 30, but remember, we don't say a negative 30%, we just say 30%, and then we use the word decrease. And there we go. Okay. All right. And then your last one for your notes today is this apply. Okay. It says the first known motion picture was filmed in 1888. First tells me it's probably the start, but let's see. It lasted for only 2.11 seconds. Today, we watch movies that last an average of about 2 hours. What's the percent of change in the times from 1888 to today? So I don't care about the 1888. I'm looking at the times. Okay. Now, here's the tricky part with this is I can't look at a percent change of different units. And so my start was 2.11 seconds. And my change or my end was 2 hours. So I either need to change the 2.11 seconds into a very small decimal hours, or I need to change the hours into seconds. Okay, so let's figure out how many seconds are in an hour. Okay, so let's think about this a little bit. So there's 60 seconds in 1 minute, right? And so if there's 60 seconds in 1 minute and there's 60 minutes in an hour, so 60 times 60, we have 3,600 seconds. Okay, and you could also just like have Googled that if you wanted to. Another thing, we've talked about proportions, right? So there's 60 minutes in or 60, oops, sorry, hold on, let me move this out of the way. There's 60 seconds in 1 minute. So you could be asking yourself, how many seconds are there in 60 minutes? And you're going to get the same type of thing. So times 60 over 60. Okay. And you can see 60 times 60 is the same thing we got. So I just wanted to connect the proportion thing with you. That we've been doing also. So we have 3,600 seconds is, that's just 1 hour is 3,600. And we have 2 hours, okay? So 3,600 times 2, we need to put that in parentheses there. Okay, so 3,600 times 2 is 7,200. Okay, so we have this here is 7,200 seconds worth of a movie. Okay, so that's my actual end right here. Okay, so let's go ahead and set it up. We have end minus start over start. So you can see why it was an apply. We had to do some extra work there. Okay, so my end is 7,200 seconds minus the start is 2.11 seconds over the start, and minus start over start. Okay, and then let's go ahead and type it all in. Okay, so in parentheses, 7,200 minus the start of 2 and 11/100ths divided by the start, and we get this number. 3411.322 and so on. That'll be good enough for right now because it does say we're allowed to round. Okay, so if we're going to take the decimal and change it to a percent, remember we're multiplying by 100, so swoop, swoop. And so here's the percent. Look at this. Rounding to the nearest whole percent. So I get to cut it right here and round. Okay, no change. 341132%. Okay, so every 3, there we go. 341,132%, and it definitely went up. Increase. That's a huge increase in percent of seconds, okay, for a movie. All right, so there you go. That was a pretty wild problem. So there are your notes. You can see a lot of similarities in this process today. So let's go ahead and take a look at your 2-1 practice homework. Okay, you're going to be doing increase or decrease, so you have to pay attention a little bit. Okay, so 8 feet to 10 feet. Okay, right away I'm going to make a little note that that's an increase. Same thing here, 62 to 31, that one's a decrease. So look at my little notes of suggestion here. I have my start and my end. So let's go ahead and end minus start over start equals 10 minus 8 over 8 equals 2/8. Okay, and so let's see what 2 divided by 8 is. 0.25. So 0.25. And then what I need to see, maybe even a different color would be good, is your 2 swoops. And then you can show that that equals 25%. Okay. All right, let's go ahead and do the next one. I would lose a point on the first one, okay, because I didn't identify it as a percent of increase or decrease. So you need to make sure that you show that word there, okay? All right, let's look at number 2 and get all the points, okay? If you think you know where it might be, the answer, you could even write the word decrease there ahead of time so you don't make a mistake. All right, let's go ahead and look at this. So here's my start, here's my end. So we do end minus start over start. 31 minus 62 over 62. Let's go ahead and calculate this. We're going to get a negative. So 31 minus 62 divided by 62, and we get negative 0.5. Negative 0.5. I'm going to go to a different color. This is just my decimal, remember, so I need to swoop, times by 100. And I end up with negative 50%. We know that that means 50% decrease. Okay, all right. Number 3 is going to be on your own to do. Let's go ahead and do number 4 together. This is just like example 1 as a word problem. The online price of the powered ride-on car was $250 this month. Here's the new price. So we have start and end. You have to label it. What's the percent of increase? They're already telling you. So if you want to write increase down here so you don't mess up, you can, or you can put an up arrow or something, but do something so you don't forget. All right, I want to see end minus start over start formula. Okay, and then you can plug in your things. So 30 minus 250 over 250. Go ahead and calculate the decimal for that. 350 minus 250 divided by the start. Oops, and don't type in wrong things. All right, 0.4. This just gets me my decimal. I still have to multiply by 100 to change it to percent. And you can see we end up with 40% increase. And there we go. Okay. All right, let's take a look at number 6. Okay, and 5 will be on your own. Realize 5 says round to the nearest whole tenth. Okay, so be careful with that one when you get there. Okay. All right, number 6. Music video website received 5,000 comments on new song they released. The next day, so that's the end, an additional 1,500 comments were made on the website. What was the percent of increase? Okay, so the start was 5,000 comments. Okay, and then there were an additional 1,500 comments made on the website. Okay, so really, this one, since we gained 1,500 comments, let's go ahead and see what that increase in comments was. So one of the things that you need to realize with this is the additional 1,500 comments. There's two things I'm thinking here is, did it end at 1,500 comments or did it really end at 6,500 comments? Okay. And so that's something to just be aware of on this one when we're talking about the end. I don't really think the end amount of comments was 1,500. The end amount of comments really was 6,500. Okay. And so we have to be really careful with some things like this when you're thinking about start and end. okay? So just pause when a problem like that occurs. Let's go ahead and do your routine. So end minus start over start. Our end amount of comments were 6,500 comments, and our start was 5,000 comments. Divided by the start, okay? And let's go ahead and figure this out. So 6,500 minus 5,000, we're left with 1,500. Let's go ahead and type it all up. 6,500 minus the original, minus the start of 5,000, divided by the start of 5,000, and we have 0.3, okay? And that's just the decimal. Let's go ahead and multiply it by 100 to change it to a percent, and we have 30% increase, okay? Because think about it, if the end was 1,500, that would be a number going down. That would be a decrease, which isn't really what happened with this one. That's why I knew that one was a little bit tricky, because I knew from start to end it wasn't a decrease in numbers. So that's something to be careful about with this one. Maybe I'll actually star that to see that tricky situation. So I guess the hint would be if it says percent increase, but you see the number from start to end go down, that means think about that one for a minute. All right, let's do number 8 together. Petra priced her scooter for $15.50, and then she ended up selling it for $10.50. Find the percent decrease. So start and end, yes, they are going down. I'm even going to write my decrease down here so don't forget. All right, so here we go. End minus start. It also says round to the nearest tenth, so that's important to be aware of. Over start. Let's go ahead and plug it in now. The end was 1075. The start is 1550 over 1550. So end minus start over start. Let's go ahead and calculate that out now. So in parentheses, 1075 minus 1550 divided by the start, 1550, okay, and we end up with a decrease as a decimal of negative 0.313, and so on. Okay, I'm just going to stop there. Okay, let's see. Let's multiply this by 100. So swoop, swoop, 2 spots. Okay, and we have 31.35, and it says round to the nearest tenth. So the tenth would be right here. Okay, and because of that 5, that's going to turn into 4. So I have 31.4% decrease. Okay, remember we don't write negative 31.4. We just use the word decrease. Okay, all right, so there's that one. Number 10, let's see, what, you have 4 problems there and 5. Number 10, let's say that one's for you as well. Okay, you can figure that one out, round to the nearest tenth, just be careful. And then number 11, let's go ahead and do a little hybrid of we take a look at it and do sum together, but you finish it. So the side length of the square shown is tripled. Okay, so here's the side, and they're tripling it, so times 3. Which percent of increase is greater? The percent of increase for the perimeter or the percent of increase for the area? So I'll do, let's see. I'll go ahead and do the perimeter one, and you can do the area one, and let's see what happens. So if I tripled this, I'm just going to, first I'm just going to figure out my perimeter anyway. So 3 plus 3 plus 3 plus 3, I'm at 3, 6, 9, 12. So my perimeter, my original P equals 12 centimeters, okay? Now, if the side length is tripled, that means I would have 3 times 3, I would have 9 centimeters by 9 centimeters, okay? So I have 9 plus 9 plus 9 plus 9, or 4 plus 9 equals a perimeter of 36 centimeters. Okay. All right. Now, the question is, which percent of increase is greater? The percent of increase of the perimeter or the percent increase for the area? So I can go ahead and do end minus start over start for this one. Okay. My end is obviously this, and my start with this for my perimeter. So 36 minus 12 over 12. Okay. So 36 minus 12 divided by 12 equals 2. Okay. So, but I still have to, here's my decimal point, I'm going to put it in there, multiply by 100. So look what that makes. So I end up with a 200%, and I'm going to write it down, increase. And this is for my perimeter. Okay. So you're going to do the same thing for area. Okay. So the original area is length times width. Okay. Or because it's a square, you can just do length squared. So 3 times 3, we have 9 cm squared. Just ignore the cm squared, it's just the units. So we go from 9 to what? If we have a 9 by 9 now. Okay, and then finish calculating the percent increase of that, and then answer the question. Which is greater, the perimeter percentage increase or the area percentage increase? And then it says, how much greater is it? So you need to actually tell us how much greater the one is than the other. So that's something you can finish on your own as well, and then we can look it over together.